So today's lesson is factoring to solve quadratic equations. What form do you think these equations need to be in order to solve them? Standard form. Everyone remember standard form? What is it? ax squared plus bx plus c equals, remember for equations we need equals 0, and that's key right there. It needs to be equal to 0. Is that okay? Okay, in yesterday's, the only time you're allowed to use the one you learned yesterday is when there's no bx. So now we're learning something that we can use when there is a bx. There's going to be 5 ways total in the end. 5. You've learned 2, you're learning the 3rd today. Yep. Okay. So the equation must equal 0. If it doesn't equal 0, you need to move stuff around to make it equal 0. The first type of problem that you're going to be given is already factored for you. It's teaching you how to solve these once you've factored. So it's easier. Don't make it harder than it is. It's already going to be factored. You're just going to learn how to solve it. Then you're going to lead into learning how to factor and solve at the same time. There's something called the zero product property. And it has to do with this whole equals 0. Okay, you're going to factor. Sometimes it's already done, like I said. Just give yourself a little question there. Is it already done? Do I even need to factor? I'm going to set each factor equal to 0 and solve for the variable. And once you solve, what did you find? Once you solve for that variable in each factor, what did you find? You found the, think about what you learned yesterday, the solutions, which are the roots, which are the x intercepts, or the zeros. Okay, so once you've solved, those are all the things you found. So these are the roots. Slash x-intercepts. And we could keep going. Zeros. And remember, they're the roots because it's when y equals what?
0.
0. Because it's on the x-axis. Okay, is everyone done? Okay, so example 1. Solve x plus 5 in parentheses times 2x minus 6. Notice it's already equal to 0. Does everyone see that? If it wasn't equal to 0, that's when this problem would become a little more difficult, because you would have to do what to these? Anyone know? You'd have to distribute, multiply them out, multiply your two binomials, and then you'd have to move whatever this number was over to make that 0. Then you'd have to go factor. So sometimes there's an added step there. But in this case, it's already equal to 0. And we've got our two factors, our two binomials. X plus 5 is one of them. 2x minus 6 is the other. You're going to set x plus 5 equal to 0 and solve. That's one root. You're going to set 2x minus 6 equal to 0 and solve. That's your other root. And there's your two solutions. So this has already been factored for you. All you have to do is take each of them, set it equal to 0, and solve. So we have x plus 5 equals 0. Common mistake here. People just take this and say x is equal to 5. You have to actually solve that. So how are we going to solve that? Subtract 5 from both sides, and we get x equals negative 5. So there's one solution. And then we take 2x minus 6, set that equal to 0, and how are we going to solve that one? Add 6. And then we have 2x equals 6 and divide by 2. And x equals what?
3.
So what are your roots?
X, negative 5.
So the roots are 3, negative 5. Why am I not putting parentheses around that?
Because it's not a point.
It's not a point. If you were to put parentheses around that, now you're trying to do x, y. It's not. They're both x's. They're the two x-intercepts. If you were going to write those as points, who knows what you would do?
Bracket.
Think about what y is equal to.
Y is equal to 0.
So how would I write these as a point?
3, 0.
So as points, these would be 3, 0, and negative 5, 0, because y is equal to 0 each time. Okay, example 2. Pretty easy, right? So don't overthink these. When you get these like that and they're already equal to 0, don't overthink them. Just take each set of factors, set it equal to 0, and solve. If you had a common factor out in the front, like a 2x, you would just set that equal to 0 and solve. What is it going to be, though? What's 2x equals 0? 0. X would be 0 in that case. Okay, example 2. Solve x squared plus 6x plus 8 equals 0. What should you always check for right away before you do anything on these? 0. Is it equal to 0? You have to check that. Get used to checking that right away. Because if it's not equal to 0, you need to do that first before you do anything else.
Wait, how would it look if it wasn't equal to 0?
It'd say equals 20. And then you'd have to subtract 20 from both sides so that you have equals 0 on the right. We're going to have an example like that. Okay, so does this look like it's probably factorable? Looks like it's probably factorable, so I'm going to go ahead and try it. In terms of tonight's homework, you know they're going to be most of the time. I don't think there's any that aren't. But once we get past tonight, you're going to have to get used to looking and checking. Does it look like I could factor to get an answer? So who remembers what we're going to do to factor?
Make 0y.
Factoring. What do we have to do with this? It's a trinomial.
AX squared.
It's a trinomial. Diamond and rectangle. Diamond and rectangle. So what am I going to underline?
X squared and 8.
X squared and 8. Positive 8. What goes at the top of my diamond? top of the diamond.
8x squared.
8x squared goes at the bottom of the diamond.
6x.
What's going to multiply to be 8 and add to be 6?
4x and 2x.
Good job. And what am I circling in here?
4x.
Circling the 4x and the 2x. What do I do to the 8x and the 6x? Cross them out. Now I go to my rectangle. What's going to go in the first box? X squared. What's going to go in the second box? Positive 4x. Third? Positive 2x. And fourth? Positive 8. Remember, you're using the first and last term. It's your middle term that's replaced with the two terms. Okay, what's your common factor in this column? Positive 4. What about this one? And what about this one? And this one? Positive 2. So our two factors are x plus 4 times x plus 2 equals 0, because it was equal to 0. So everyone see how this is the exact same thing? Okay, this one's factored, that one's multiplied out. Same exact thing now. So now what are we going to do to actually find our roots? Take each of them and go up to example 1. Now that you've factored, you do exactly what you did in example 1. So go up here, x plus 4 equals 0, and x plus 2 equals 0. And what are we going to have here? Subtract 4, and we get x equals negative 4. And what are we going to do on the other one? And we get x equals negative 2. So those are your roots, or your x-intercepts. So x equals negative 4 and negative 2. Yes. Hurry. Okay, any questions about that? All right. Example 3. This is when the equation is not equal to 0. This is an example of that. Solve 2x squared subtracting 5x equals 88. Okay, so it's not equal to 0. What are you going to do to get it equal to 0?
Subtract 88.
Subtract 88 from both sides of the equation. And now you have 2x squared subtracting 5x subtracting 88 equals 0. Now you have a trinomial. So because you have a trinomial, what are you going to do? Diamond and rectangle. There was no common factor because 2 doesn't go into 5. So what's going to go at the top of the diamond? It's a negative, right? Negative 176x squared. And what's going to go at the bottom? Negative 5x. That's a 5. Okay, these aren't fun numbers to deal with, but if you're trying to think about differences of 5, just give me a quick number that you think might be somewhere around 176. It would have a difference of 5. 20 and 15 have a difference of 5, right? So if you think about 20 times 15, you're at 300. Too big. So what are two other numbers that you could think of?
15 and 10.
15 and 10, you already know that, though. It's 150, right? So that's closer. 11 and what?
16 and 9.
16 and 9.
11 and 16? 11 and 16 make 176. So now which one has to be positive, which one has to be negative? We have one positive, one negative. Which one is 11?
Negative.
11's the negative? Is 11 the negative?
No, 16.
16 is the negative.
No, it's changed back.
Because remember, you want a negative answer here. And these can be reversed. If you have your negative 16 over there, that's fine. But the negative needs to be with the 16. It can't be with the 11. How do I know that this needs to be negative? Because a negative 16 plus 11 is a negative 5. If I had a positive 16 minus 11, it would be positive 5. So the opposite signs make the negative there. But then you need to make sure you get the right sign when you add. Okay, now set up your rectangle. What's going to go in the first square? 2x squared, then what? Plus 11x, minus 16x, minus 88. And what's your common factor here?
11.
Positive 11. What's your common factor here?
Positive 2x.
Positive 2x. Here?
Positive
Just an x. And here? Negative 8. And if you got stuck there, 11 times what gives you 88? 8. Now you check it. So x times 2x is 2x squared. X times 11, 11x. 2x times 8, negative 8. Negative 16x, negative 88. So now you have your two new factors, which are 2x plus 11 times x minus 8 equals 0. And what are you going to do to actually find the roots? What do you do to find the roots? Set each of them equal to 0. 2x plus 11 equals 0. X minus 8 equals 0. How are we going to solve this one?
Subtract 11 both sides.
Subtract 11. 2x equals a negative 11.
Divide by 2 both sides. That's not.
Divide by 2. X equals a negative 11 halves, or how can you put that as a decimal? Negative 5.5. And then how are you going to solve the other one?
Add 8 to both sides.
And what does x equal? So the roots, or the x-intercepts, or the zeros are negative 5.5 and 8. Okay, one more. So this is the one that has the most steps to it, and I'll show you why. Everyone done?
Yes.
No? Everyone got it? Maddie, you're done? Okay. Are you sure? Okay. Okay, so example 4. I'm not going to write anything on the left unless you want to add something.
No, I'm good.
It says solve x plus 8 times x plus 6 equals 288. This is the one I was talking to you about. It's not equal to 0, which means that I'm actually going to have to multiply these out then subtract 288 to start with something I can refactor. So you're going to multiply these. I guess I'll put a little bit. You're going to multiply the binomials, then set the equation equal to 0. Factor and solve. Okay, so you're going to multiply the binomials, then you're going to get the equation equal to 0, then you're going to factor and solve.
When you multiply them, can you do a rectangle?
When you multiply these, you can do a rectangle to multiply them, or you can use just like the FOIL distributing method.
Wait, can you screen?
Which way is it not showing? Sorry. So don't multiply these out if this is already equal to 0. Think example 1, really easy. It's when it's not equal to 0 you have to take the extra step there. Raise your hand if you use the rectangle to multiply these out now. Raise your hand if you just use the distributing correctly. Most of you are using distributing. Okay, let's make sure we're doing it correctly then. So what is x times x?
Squared.
X squared
Plus 6x.
plus 8x
Plus 48.
plus 48 equals 288. Now what can you combine in there?
6x and 8x.
Combine these and you get x squared plus 14x plus 48 equals 288. Now what are you going to do?
Subtract 48.
Diamond?
Oh, done. No.
Go read the left side. What do you need to do?
Subtract 288.
Subtract 288 because we need it equal to 0 before we can factor. If you were to factor that, you already know your answers. What are they? Yeah, x plus 6, x plus 8, right? So that would be a waste of your time there. Okay, subtract 288, subtract 288. You end up with x squared plus 14x subtracting 240 equals 0. Now that we have that,
Diamond?
we can actually start factoring. So trinomial, so what are you going to have with a trinomial? Diamond. Underline your x squared and your negative 240. What goes at the top?
Negative 240x squared.
Negative 240x squared. What goes at the bottom?
14x.
Positive 14x. Because we have a negative here, we know we're looking for a difference, right? So one positive, one negative. Think about numbers that have a difference of 14 that might multiply to be around 240.
12 and 2. Oh, wait, no.
12 and 20, you mean? Nope, that's not the difference of that, though. What? 20 and 24? Oops, not divided. Oops, what am I doing? I can't use the calculator right now. 24 times 20.
That's only 5 more.
What am I doing?
24 and 10.
24 times 20 times.
There it goes. 480. Okay.
24 and 10.
What?
24 and 10.
24 and 10. Is the difference between 24 and 10 14?
Yes.
And is it 240?
Yeah.
Okay, so now which one needs to be positive, which one needs to be negative? 24 should be positive because it needs, the larger number needs to be positive here. 10 should be negative. You guys are getting better with these big numbers now. Okay, what's going to go in the rectangle?
X squared.
X squared
Plus 24x.
plus 24x, subtracting 10x, subtracting 240. Remember, don't use those.
X.
Okay, what's your common factor here?
24.
24. Common factor here. X. Common factor here. X, common factor there.
Or negative 10.
Negative 10. Check it. Does it work? Okay. So now you have x plus 24 times x minus 10 equals 0. What are you going to do with these to find your roots? X plus 24 equals 0, and x minus 10 equals 0.
X equals negative 24.
Subtract 24. X equals negative 24, and
X equals 10.
x equals 10. So your roots or your x-intercepts are negative 24 and 10. That's going to be a really wide graph, isn't it? In terms of where it's going to reach at the x-axis there. Okay, the only other kind that I didn't show you an example of, but you guys should know, there's going to be trinomial squares in your homework, and there's going to be differences of squares. When you get to a difference of squares, something like this, you don't have to write it down, but just think about it. X squared minus 81 equals 0. Do you guys know how to solve those? Or how to factor them, I mean? What is it? X minus 9 times x plus 9 equals 0. So you'd end up with 9 and negative 9, right? Okay, now look at yesterday's. Think about how we learned how to solve yesterday. No bx. So what would you do?
Add 81 to 0.
Add 81.
Find the square root.
And you get x squared equals 81. And then what would you do?
Find the square root of
X equals 9.
Square root with a plus or a minus. And you'd have x equals plus or minus 9, right? Two ways to solve the difference of squares ones, because they have no bx. You can factor them and solve, or use the square root and solve. The only time you can do that is when there's no bx. If there's a bx, you cannot choose that way. So if you see a difference of squares, you can use either or. I'm okay with either or. Okay, your homework is, if you have questions from last night's homework, you're going to ask Mr. Montoya or I. And if you have questions on tonight's, ask one of us. So we'll both be walking around and helping if you need help.
It's still recording.
Your homework is page 454, 1 through 21 odd, 27 through 31 odd, 39 and 41.
That's it.
I could give you more.